In engineering and science, we always deal with various physical variables. In differentiation, we deal with small differences or increments in the values of various physical variables. Whereas in integration, as the name indicates, we deal with summation or integration of these small differences to get total difference or total change in the value of a given variable. Thus, integration is a reverse process of differentiation. We will also see that graphically the integral of a function is the area under the curve of that function. You must have seen that we cannot think of learning engineering and science without the knowledge of differentiation. Similarly, the knowledge of integration is equally important. Now we will see how the process of integration is reverse of the process of differentiation. Let us consider the graph y is equal to x cube. As x changes from 0 to 2, y or x cube changes from 0 to 8. Thus, the total change in y is equal to 8 minus 0, which is equal to 8. We see that the total change in y is the sum of many small changes or differences in y as shown. Therefore, total change in y is equal to sigma delta y. Y varies from 0 to 8 is equal to delta y1 plus delta y2 plus delta y3 plus delta y4 plus delta y5. According to the definition of differential coefficient, we know that at any point xy, limit of delta y upon delta x as delta x tends to 0 is equal to dy upon dx, or delta y upon delta x is approximately equal to dy upon dx slope, or delta y is approximately equal to dy upon dx into delta x. As dy upon dx is equal to differential coefficient of x cube, which is equal to 3x square. Therefore, delta y is approximately equal to 3x square into delta x. Here, delta y is the small difference or change in the value of y corresponding to a small difference delta x in the value of x. The relation 1 has been obtained by using process of differentiation. To get total difference or total change in the value of y, we have to add up all small differences in y as given by 1. This summation is called process of integration. Therefore, total change in y is equal to sigma delta y when y varies from 0 to 8 is equal to summation 3x square delta x when x varies from 0 to 2. If the total interval from x is equal to 0 to x is equal to 2 is divided into n is equal to 5 equal parts, giving delta x is equal to 2 over 5, which is equal to 0.4. The total change in y is equal to summation delta y varies from 0 to 8 is equal to delta y1 plus delta y2 plus delta y3 plus delta y4 plus delta y5, which is approximately equal to sigma 3x square delta x varies from 0 to 2, which is equal to 3 into 0 square into 0.4, the value of delta y at x is equal to 0, plus 3 into 0.4 square into 0.4, the value of delta y at x is equal to 0.4, plus 3 into 0.8 square into 0.4, the value of delta y at x is equal to 0.8, plus 3 into 1.2 square into 0.4, the value of delta y at x is equal to 1.2, plus 3 into 1.6 square into 0.4, the value of delta y at x is equal to 1.6, which is equal to 1.2 into 0 square plus 0.4 square and so on, plus 1.6 square, which is equal to 5.76. Whereas we have seen that the total change in y is 8. Therefore, the total error in calculated value of total change in y is sigma e is equal to 8 minus 5.76, which is equal to 2.24, which is the sum of all errors indicated by E in the figure. If the number of divisions n is equal to 10 and delta x is equal to 2 over 10, which is equal to 0.2, then total change in y is equal to sigma delta y varies from 0 to 8 is equal to delta y1 plus delta y2 and so on plus delta y10, which is approximately equal to sigma 3x square delta x varies from 0 to 2, which is equal to 3 into 0 square into 0.2, the value of delta y at x is equal to 0, plus 3 into 0.2 square into 0.2, the value of delta y at x is equal to 0.2 and so on, plus 3 into 1.8 square into 0.2, the value of delta y at x is equal to 1.8, which is equal to 0.6 into 0 square plus 0.2 square and so on plus 1.8 square, which is equal to 0.6 into 11.4, which is equal to 6.84. And the total error sigma e is equal to 8 minus 6.84, which is equal to 1.16. Similarly, if n is equal to 20 and delta x is equal to 2 over 20, which is equal to 0.1, then total change in y is equal to sigma delta y varies from 0 to 8, which is approximately equal to sigma 3x square delta x varies from 0 to 2, which is equal to 7.41. and the total error sigma e is equal to 8 minus 7.41, which is equal to 0.59. If n is equal to 50, then total change in y is equal to sigma delta y varies from 0 to 8, which is approximately equal to sigma 3x square delta x varies from 0 to 2, which is equal to 7.7616, and the total error sigma e is equal to 8 minus 7.7616, which is equal to 0.2384. The summary is given in the table. When number of divisions n is equal to 5, the value of delta x is equal to 0.4, and the value of sigma 3x square delta x is equal to 5.76, and the corresponding error is 2.24. Similarly, when n is equal to 10, delta x is equal to 0.2, then sigma 3x square delta x is equal to 6.84, and error is 1.16. When n is equal to 20, delta x is equal to 0.1, then sigma 3x square delta x is equal to 7.41, and the error becomes 0.59. And when n is equal to 50, delta x is equal to 0.04, then sigma 3x square delta x is equal to 7.7616, and the corresponding error becomes 0.2384. Thus, on increasing the value of n and consequently decreasing the value of delta x, the error in the calculated value of sigma 3x square delta x goes on decreasing, and its value becomes more nearer to 0. If n tends to infinity and delta x tends to 0, then limit of sigma delta y as delta y tends to 0 is equal to limit of sigma 3x square delta x as delta x tends to 0, which is equal to 8. In the limiting case, when delta y tends to 0 and delta x tends to 0, the error in the calculation of sigma 3x square delta x is 0. Delta y and delta x are replaced by dy and dx respectively, and the summation sign sigma is replaced by sign of integral, which is the first letter s of the word summation occupying less space. Therefore, integral of dy when y varies from 0 to 8 is equal to integral of 3x square dx when x varies from 0 to 2 is equal to 8. Here 0 and 8 are called respectively the lower and upper limits for y, and 0 and 2 are respectively lower and upper limits for x. From above, integral of dy when y varies from 0 to 8 is equal to 8. Now, left hand side is equal to integral of dy limits varies from 0 to 8 is equal to y varies from 0 to 8, which is equal to 8 minus 0 or 8. We say that dy is the differential of y and integral of dy is y. Dx is the differential of x. Also, x cube when x varies from 0 to 2 is equal to 2 cube minus 0 cube, which is equal to 8. Therefore, integral of 3x square dx as x varies from 0 to 2 is equal to x cube when x varies from 0 to 2. Thus we see from the above that if y is equal to x cube and x changes from 0 to 2, then x cube changes from 0 to 8, and the total change in x cube is 8 minus 0, which is equal to 8. This total change can also be obtained by first differentiating x cube and getting dy dx of x cube, which is equal to 3x square, and then secondly integrating 3x square, getting integral of 3x square dx, x varies from 0 to 2. Thus, the change in the value of x cube as x varies from 0 to 2 is equal to 8. On applying the process of differentiation, differential coefficient of x cube is equal to 3x square. Now, if we apply the process of integration, then integral of 3x square dx, x varies from 0 to 2 is also equal to 8. Thus we see that process of differentiation and process of integration are reverse processes, because when both applied in succession result the original total change in the value of a given function, 8 in this case. If the limits are omitted, we get integral of 3x square dx is equal to x cube. An integral with given limits is called a definite integral because it has a definite value. Integral of 3x square dx as x varies from 0 to 2 is equal to x cube, x varies from 0 to 2, which is equal to 8. An integral without limits is called an indefinite integral. Therefore, integral of 3x square dx is equal to x cube. We have seen that integration is the reverse process of differentiation. In addition to it, we will see that integration also means the area under a given curve. Let us see how it is. Let us see the graph of the curve 3x square. Take a point P whose coordinates are x and 3x square on it. Then 3x square into delta x is the area of a rectangular strip ABCP. If the total area under the curve and between x is equal to 0 to x is equal to 2 is divided into 5 such strips, giving delta x is equal to 2 divided by 5, which is equal to 0.4. Now, area of the first rectangle is equal to 3x square delta x is equal to 3 into 0 into 0.4. Similarly, the area of the second rectangle is equal to 3x square delta x is equal to 3 into 0.4 square into 0.4. Area of the third rectangle is equal to 3x square delta x is equal to 3 into 0.8 square into 0.4. Area of the fourth rectangle is equal to 3x square delta x is equal to 3 into 1.2 square into 0.4. And finally, area of the fifth rectangle is equal to 3x square delta x, which is equal to 3 into 1.6 square into 0.4. Therefore, the total area is approximately equal to sigma 3x square delta x when x varies from 0 to 2, which is equal to sigma 3x square into 0.4, which is equal to 1.2 sigma x square, which is equal to 1.2 into 0 plus 0.16 plus 0.64 plus 1.44 plus 2.56, which is equal to 1.2 into 4.8, which is equal to 5.76. The error in calculating the area under the curve is equal to the area of shaded portion above rectangles. If total area is divided into 10 strips, then delta x is equal to 2 over 10, which is equal to 0.2. Now, area of the first rectangle is equal to 3x square delta x is equal to 3 into 0 into 0.2. Similarly, area of the second rectangle is equal to 3x square delta x is equal to 3 into 0.2 square into 0.2. Area of the third rectangle is equal to 3x square delta x, which is equal to 3 into 0.4 square into 0.2, and so on. And finally, area of the last rectangle is equal to 3x square delta x, which is equal to 3 into 1.8 square into 0.2. Therefore, the total area is approximately equal to sigma 3x square delta x. X varies from 0 to 2, which is equal to sigma 3x square into 0.2, which is equal to 0.6 into sigma x square, which is equal to 0.6 into 0 plus 0.2 square plus 0.4 square and so on plus 1.8 square, which is equal to 0.6 into 11.4, which is equal to 6.84. You can see that the error in calculating the area, which is denoted by shaded portion above rectangles, in this case has decreased compared to the case when n was equal to 5. If the total area is divided into 20 strips, then delta x is equal to 2 over 20, which is equal to 0.1. Now, area of the first rectangle is equal to 3x square delta x, which is equal to 3 into 0 into 0.1. Similarly, area of the second rectangle is equal to 3x square delta x, which is equal to 3 into 0.1 square into 0.1. And finally, area of the last rectangle is equal to 3x square delta x, which is equal to 3 into 1.9 square into 0.1. Therefore, the total area is approximately equal to sigma 3x square delta x when x varies from 0 to 2, which is equal to sigma 3x square into 0.1, which is equal to 0.3 sigma x square, which is equal to 0.3 into 0 plus 0.1 square plus 0.2 square plus 0.3 square and so on plus 1.9 square, which is equal to 0.3 into 24.7, which is equal to 7.41. It is obvious from the figure that the error in the calculation of the total area has been further reduced by taking 20 divisions instead of 10. If total area is divided into 50 strips, then delta x is equal to 2 over 50, which is equal to 0.04. Now, the total area is approximately equal to sigma 3x square delta x, which is equal to sigma 3x square into 0.04, which is equal to 0.12 sigma x square, which is equal to 0.12 into 0 plus 0.04 square plus 0.08 square and so on, and finally plus 1.96 square, which is equal to 0.12 into 64.68, which is equal to 7.7616. Thus we see that as the number of strips n is increased, the total area under the curve 3x square goes on increasing and is tending to a definite value 8. Thus we can write that if n tends to infinity and delta x tends to 0, limit of sigma 3x square delta x as delta x tends to 0 is equal to integral of 3x square dx when x varies from 0 to 2 is equal to 8, which is equal to area under the curve 3x square between x-axis and the ordinates x is equal to 0 and x is equal to 2. Therefore, integral of 3x square dx x varies from 0 to 2 is equal to x cube x varies from 0 to 2, which is equal to 2 cube minus 0, which is equal to 8. In general, we can say that integral of fx dx x varies from a to b is equal to the area under the curve fx between x-axis and the ordinates x is equal to a and x is equal to b. Thus we see that integration is the reverse process of differentiation, and graphically it represents the area under a curve.